Good morning. Welcome back. It's me, your presenter, your MC, and today we're going to talk about some things. Now, first of all, um so the weather is nice. It's sunny, the clouds is singing, the birds are flapping. And today we are going to talk about the goodness fitness test. And it is quite an interesting topic, yeah, because fitness is very important and we need a test to make sure that everyone you know and you're taking care of is indeed fit enough to continue, because it is very important. Your physical health is very important, but you also got to remember that mental health is also important. Now, we are gonna discuss, talk, and analyze what exactly is the goodness of fit test. Well, to answer your question, the goodness of fit test is one of the most commonly used statistical tests, if not the most used statistical test. It is particularly useful because it requires only the nominal level of measurement. So, we are able to conduct a test of hypothesis on data that has been classified into groups. Our first illustration of this test involves the case when the expected cell frequencies are equal. As the full name implies, the purpose of goodness fit test is to compare and observe and analyze the distribution to an expected distribution. And we are gonna discuss about what does a chi-square, which is goodness of fit, exactly do. Like, how does it work? What is it all about? What's all this hype about? Well, chi-square is used to test hypotheses about the distribution of observations in different categories, and the null hypothesis, which is whole, is that the observed frequency are the same as the expected frequency. Well, except for the chance variation, yeah, that is excluded from that. And if the observed and expected frequency are the same, then the x2 is equal to 0, and that is quite unique. If the frequencies you observe are different from expected frequency, the value of x2 also goes up, or as they'll say, increases. And why does the x2 matter? Well, the larger the value of x2, the more likely it is that the distribution are significantly different. Test procedures in SPSS statistics. Now, the 4 steps below shows you how to analyze, how to look, and how to detailize your data using a chi-squared goodness of fit test in SPSS statistics. When you have hypothesized that you have equal expected proportions, and if you're unclear about the difference between equal and unequal expected proportions, you can see the introduction. Also, if it is important to note that this procedure will only give you the correct results if you have already set it up your data correctly and nicely in SPSS statistics. In our enhanced chi-squared goodness of fit test guide, we show all the SPSS statistic procedures for when you have equal and unequal expected proportions, as well as when you have to weight your cases or have not submitted your data. If you only need to follow this quick start guide for equal expected proportions without actually the weighting of cases, now the 4 steps you have to or you need to are shown below. At the end of these 4 steps, we show you how to interpret the result from this test. Now, on step number 1, you have to try to find and click the Analyze taskbar in the upper corner, as you can see in the picture, and then you choose the Nonparametric test. And after you chose that, then there should be a legacy dialogues, and you have to click that as well. And then finally you get the chi-square, and it is all on the top menu as shown below. And after you actually done the first step, the second step is you will be presented with the chi-square text dialog box as it is shown below. Now you can look at it, and there's actually a gift type and a frequency and a bunch of other stuff that we will explain later. And then step number 3, after you completed step number 4, you can go ahead and transfer the GIF type into the variable test list box by using the forward button as shown below. And that is the forward button, and you can click that to move the GIF type, and then keep all categories equal option selected in the expected values area, as we are assuming equal proportions for each category. And then after that, step number 4 and the last step, you can go ahead and click on the OK button to generate the output you desired. Now we're gonna move on to the examples. Let's say you want to know if gender has anything to do with political party preferences. Your poll 4,400 voters in a simple random sample to find out which political party they prefer. Now the results of the survey are shown in the table below. You can look at the table. There's Republican, Democrat, Independent, and the total. There is also the male, female, and total. To see if gender is linked to political party preferences, perform a chi-square test of independence using these steps below. And the first step is to define the hypothesis. And there's two hypotheses, HO and H1. And for HO, there is no link between gender and political party preferences. And H1, there is a link between gender and political party preferences. Now, there is a difference between HO and H1. And then onto the step number 2. You can calculate the expected values. Now we will calculate the expected frequency. Expected value is row total plus column total divided by the total number of observations. For example, the expected value for male Republicans is 240 plus 200 divided by 440, which is 109. Similarly, you can calculate the expected value for each of the cells. And you can see the cells. There's Republican, Democrat, Independent total, male, female, and total. You can calculate it based on the table. Step 3. You can calculate the parentheses O minus E parentheses 2 divided by E for each cell in the table. Now you will calculate the O parenthesis O and minus E parenthesis times 2 divided by E, where O is observed value and E is expected value. You can see the table there for the results. Step number 4. Calculate the test statistic, which is x2. Now, x2 is the sum of all the values in the last table, which is 0.743 and 2.05, 2.33, 3.33, 0.384, and 1. And if you add that all up, it equates to 9.837. Now, before you can conclude, you must first determine the critical statistic, which requires determining our degrees of freedom. Now, degrees of freedom in this case are equal to the table's number of columns minus 1 multiplied by the table's number of rows minus 1, or parentheses R minus 1, parentheses C minus 1. We have 3 minus 1 and 2 minus 1, which is 2. Finally, you can compare our obtained statistic to the critical statistics found in the chi-square table. As you can see, for an alpha level of 0.05 and 2 degrees of freedom, the critical statistic is 5.991, which is less than our obtained statistic of 9.83. You can reject our null hypothesis because the critical statistic is higher than your obtained statistic. This means you have sufficient evidence to say there is an association between gender and political party preferences. And that is all from me. Thank you for listening. Peace out.